Alright, we're going to differentiate by first principles. So remember, by first principles, y dash is the limit as h goes towards 0, h gets really, really small, of x plus a little bit, so plus h minus f of x, all on x plus h minus x, which is h. Alright, so in this case we've got the limit as h goes to 0 of log x plus h minus log x on h, and we can write that instead as log of x plus h on x on h, like that. And then there's two ways to go here. So we could go, I'll do it over here. We could go like this, log x on x is 1 plus h on x. So log of 1 plus h of x on h. Oh, here we go. Alright, and then if you think about it, that h is like, so 1 on h log of blah blah blah. So that we can put up as a power as well if we would like. So we could say that y dash is the limit as h goes towards 0 of log 1 plus h on x to the power of 1 on h. So that's one way you can do it. And the other way, if we go from here, is y dash equals the limit as h goes to 0. Now, if we keep it as log 1 plus h on x here, on the bottom we've got h. What I can do though is times it by x, and divide it by x at the same time. So I'm not really changing it, but what I can do then is this, think of this as 1 on x. I'll put that at the front, 1 on x. The limit as h goes to 0 of log 1 plus h on x, like that. Now we know, let me rub that bit out. We know that the limit, if I take the limit of x, sorry, let's say, I need to use a different letter, not h, not x, p, as p goes to 0, of a log that is 1 plus p on p, that's 1. Alright, so if we use that property that the log of 1 plus a tiny bit divided by that tiny bit is equal to 1, then you can see here's like p and this is p here. So that's going to go towards 1, which means we'll just get the 1 on x left for our y dash. Alright, so because of that, we can then use that. Yeah, so we're kind of up to c here. So if we use that, let me rub that out. Alright, so we're substituting into y dash the limit as h goes to 0 log base e 1 plus h on x to the 1 on h, and we're putting h is n, so h is 1 on n, so 1 on n goes towards 0 log base e 1 plus, so h here is 1 on n, h is 1 on n, but x is 1 on u, so that'll be u, and then we've got to the power of 1 on h, which is n. Tricky, and we know that equals, we just said 1 on x, so 1 on x is, in this case, 1 on x is u. Alright, so we've almost got this first one, because we've got the 1 plus u on n to the power of n, and we've got, that should be oh no, that should be U, that's correct. Alright, so what we want to do is a couple of things. We want to get rid of log, so we want to exponentialize like these two parts, the left hand side and the right hand side. And we can also change our, what do we have? We've got our, let me change that part. So if I make E, if I exponentialize both sides, I'll get 1 plus U on n to the n, and this side will become e to the u. So we've got that bit and that bit. So I'm just looking at the limit here. So the limit, so it was 1 on n going to 0. For 1 on n to go to 0, that means n is going towards infinity. So that was just swapping, doing a substitution, and then just rearranging it using our log laws, kind of exponentializing both sides. And then of course, if I let let u equal 1, that will give me the limit as n goes to infinity of 1 plus 1 on n to the n, being, so u goes to 1. So that goes to e, the number e. So what we can do is have a look at how fast this converges to e using different values of n in here. So if I was just looking at this section, oops, not even that, just this really, 1 plus 1 on n to the power of n, and I use n equals 1, let's have a look. So, alright, so let's use n equals 1, so we get 1 plus 1 on 1, so 2. So we get 2 to the power of 1, which is 2. So that one will be 2. When we use 10, we've got 1 plus 1 on 10 to the power of 10. I need my calculator. So that one I think is 2.5937-ish. And when I put n equals 100 in, I get 2.7048, so I'm getting closer. When I put 1,000 in, I get 1 plus 1 on 1,000 to the power of 1,000, 2.7169. And when I put 10,000, 2.7181. So you can see, I mean, if you put your E into your calculator, you'll see 2.718281828. So we're pretty close. 2.7181 is pretty close, but yeah. So that's just if you want to investigate it.